We're starting the trig unit today.
Started what?
We started the trig unit today.
Oh, okay. So let's see how much you've learned. What is the sine of theta?
3/5.
It's cosine of theta?
4/5.
And the tangent of theta?
3/4.
And the cosecant of theta?
Cosecant would be 1/sine. So 5/3.
Right, it's just the reciprocal of sine. The secant would be the reciprocal of cosine, and the cotangent would be the reciprocal of tangent. Okay?
Yeah.
That's a good start.
Okay, so we have bookwork. So, first question. F of x equals 10 of x.
I'm sorry, what?
Nothing. I'm trying to find questions that need to go over.
Mm-hmm.
Alright, so these are application problems.
Okay.
A bacteria culture contains 1,500 bacteria initially and doubles every hour. Find a function that models the number of bacteria after t hours.
Okay. This is not a trig, but this is a exponential. What's the standard exponential equation?
E naught to the power of kt.
Like that. Where a sub 0 is the initial
A sub
amount.
0.
Well, whatever you use for this, that's the initial amount.
Yeah, I just needed something in front of the e.
And then y is the amount at any point in time. So whoops. So we know this much.
So y equals 1,500 EKT.
Unfortunately, we have two variables there. So that's not really the answer they're looking for. They give us one additional piece of information, and that is that it doubles every hour.
So it would be 3,000 equals 1,500 EK.
Beautiful. Solve for k, and then we'll have our specific equation for this model.
ln of, no, you divide the 1,500, yeah, 2. So the ln of 2 equals ln of k.
Equals k. In other words, if I take the natural log of both sides, remember that when you take the natural log of e to some power, it's equal to that power.
Yeah. Alright, then
So
find
now
the number of bacteria.
is y equals 1,500 e to the natural log of 2 times t. So there is our specific equation for this bacteria culture. Now what's their question?
It's just plug 24 in, but I can do that.
Okay. All right. In other words, how much bacteria is there after 24 hours?
Yeah.
Okay.
So, your numbers 3, 19, and 31. Find the exponential function. Alright. So, This one, find the exponential function of the graph. And it gives me a picture of the graph.
Okay, these are the kind that are going to be hard to do with you verbally giving it to me. These are the kind where you probably need to take a picture of that and email it to me.
Yeah.
And while we're waiting for that email, we can maybe do another problem that you can verbally give me.
Graph the function not by plotting points, but by starting from the graphs in figure 2.
Okay. What's the function?
State domain range and asymptote. The first function is f of x equals negative 3 of x.
Okay. So first of all, let's graph it based not on plotting points, but based on plotting the elementary function, which is what?
Negative x.
Y equal x.
Oh, it's 3 to the negative 3 to the power of x. So,
Excuse me. Okay. So the standard function is y equal 3 to the x. What does that look like? What point does that go through? What point do all exponential functions go through?
They go through 0, 1. And the 3 just determines like the shape, kind of.
Right.
Like the
In other words, it's really hard to distinguish between 3 to the x and 2 to the x and 10 to the x, because they all go through this point and they all look like this. They're all asymptotic with the x-axis. So the question is, what does this negative 3 do?
Inverse it. Or reflects it. I think it's reflection on the x-axis. Or y. Yeah, y. Y. It's a flip. It's an invert on the y-axis. There you go.
Actually not. If to reflect on the y-axis, we would need the negative sign in front of the x. In other words, if I had y equal 3 to the negative x, that would be a reflection about the y-axis. If I had y equal minus 3 to the x, that's a reflection about the x-axis. Is that what this was, or was the negative 3 in parentheses?
No, there wasn't. It's just, oh, it is negative 3, yeah. It's outside the parentheses.
So it's like this.
Yeah, it's like that.
That's good, because the other one would have been tough to plot because it would have been given us positive and negative y values depending on whether x was odd or even. So this one is 3 to the x reflected about what axis?
X. So basically all graphs of the power of x are almost the same. They're just a little bit different in the shape.
Yeah, I mean, right, unless they have some vertical shifts or horizontal translations or something.
Yeah.
What is the domain of this?
Domain, negative infinity to infinity.
All real? Okay. What's the range?
And I'm guessing it's going to be in parentheses 1, 2, no. Negative 1.
Look at the
2,
y-axis.
or 0.
There you go.
0
In other
to
words,
negative infinity.
once you've graphed it, figuring out the range is pretty easy because we're looking at this graph. And what do the y's do? They go from 0 to negative infinity, only we don't write it like that. We start from the bottom and go up. So it's negative infinity, comma 0. I don't know if you'd lose points or not if you put 0, negative infinity. You might. Proper interval notation.
No, I think I probably would.
Would you? Yeah. Proper interval notation either goes from left to right or from bottom to top.
Mm-hmm.
And then the last thing was asymptotes. What kind of asymptotes do we have on this?
Just a horizontal at 0.
Y equals 0.
Yeah.
Okay. In other words, an asymptote is the equation of a line. So it's got to be a y equals something or an x equals something. Okay.
So the next one is just 2 to the power of x minus 3. Would that minus 3 move it down 3? No. It's 2 to the power of x and then minus 3.
Okay. Yes. It's the same function as 2 to the x, only vertical shift down 3.
Okay.
Notice that if that was up there, what would that be?
Okay, so that, I'm guessing, right 3.
Yes. Horizontal shift
Yeah.
to the right. And if it was that,
It'd be a reflection.
about,
Y-axis.
and if it was this,
X-axis.
okay.
Alright, so 4 plus, in parentheses, 1/2 to the power of x. So I'm guessing that is, you move that to 1/2 to the power of x plus 4, so moves up 4.
Yeah, so let's do that. First step, let's put our vertical shift last where it belongs.
So then the 1/2, would that make it kind of like steeper, not as wide?
When this number is less than 1, notice that if we take numbers greater than 1 and we take them to exponents, they get bigger. So they go like this. But if we take numbers between 0 and 1 and we start squaring them or cubing them, what happens to them?
It gets like smaller,
They get smaller.
not as like wide.
This one must be this. And what's this point that they still all go through?
0, 1.
Because when you plug in 0, that's equal to 1.
Well, why is that graph so big though?
Well, first of all, this is y equals 1/2 to the x.
Yeah.
When you say
I
y
thought it was
is so
supposed to be
big,
smaller.
smaller how?
Just like
We've got to go through that point, but
I'm saying, like when you bring it out, like don't bring it out as much, you know. I don't know how to explain that.
well, the shape is the shape, and I don't know that the shape really matters. The only thing that matters is that it goes to positive infinity on the range down to 0, and the domain goes negative infinity to positive infinity. And the y-intercept is 0, 1. All of that applies just to that part there.
Right.
Notice why it's high to the left of the x-axis when x is negative. If I took 1/2 to the negative 2, that's the same as 1 over 1/2 squared, which is 1 over 1/4, so that's equal to 4. So as x gets negative, y becomes positive, and it gets bigger the more negative x is. If I had 1/2 to the minus 10, that's 1 over 1/2 to the 10th, which is 1 over 1,000, so that's equal to like 1,000. So as x goes to the left, y gets bigger. As x goes to the right, notice if x is 1,000,000, 1/2 to the millionth power is going to be almost 0. So whenever you plot fractions to an exponential, remember it has a shape that looks like it's been reflected about the x-axis. has exactly the same shape as if we took a normal-looking exponential curve and reflected it about the x-axis. So the only thing we need to do is add the 4, which does what?
It moves it up 4.
So everything goes through that point.
0, 5.
And what about the horizontal axis?
What do you
Or the
mean?
horizontal asymptote?
Oh, wouldn't it just be y equals 0 still?
No? Notice that if y is equal to 1/2 to the x plus 4, x can be anything from negative infinity to positive infinity, but this quantity right here can never be 0, always has to be positive.
Oh, that makes sense. Okay, so there's no asymptote then.
There is. It's at 4, y equal 4. In other words, our curve is going to look exactly the same as this curve here, only it's going to be asymptotic with the line y equal 4. So it'll look something like this.
So for every equation I get that looks like that, that plus 4, whatever number that is going to be the asymptote?
Yeah, if it looks like this, yes.
Okay.
Because
So
this
the
can
vertical
never be
shift
0.
up.
That can never be 0, that can never be negative. So there's no way y can even ever equal 4. It can only approach it.
Yeah, that makes sense. Okay.
All right.
Let's try the graph of...
Now, you say you started trig today, or do you still have to do you still have to take tests over this exponential stuff? I mean, is this new review?
No wonder. We're in chapter 5. I was looking at chapter 4 for some reason.
Okay.
I knew something was wrong. Alright, now I'm... So, 1 to 45 odd. So find the reference number and the terminal point.
Okay.
The first one would be t equals 2 pi over 3. So let me try and solve this one first. T equals 2 pi over 3. You go over the second quadrant. So the reference number would be pi over 3.
Okay.
And the terminal point would be negative 1/2 comma root 3 over 2.
Negative 1/2 times comma 3 over 2, so minus 3
That's the terminal point.
over 4. You're talking about this point right there? On the unit.
Yeah. Well, I thought the terminal point you didn't have. That's just the point, like 1/2 comma root 3 over 2.
Let me redraw this. T equals 2 pi over 3 is an angle.
Mm-hmm.
Okay, it's that angle right there. If this is my unit circle, this angle is 2 pi over 3. So the reference angle that they're asking about is this one right here.
The distance from the x-axis.
The reference angle is always the angle that the ray makes with the x-axis. So this angle, since this one and this one have to equal pi, this must be pi over 3. Because they have to equal 180 degrees. They're supplementary.
Yeah.
Okay? So now,
Yeah,
what they want is that point right there. Well, what angle?
Pi over 3 is...
What angle is pi over 3?
1/2 comma root 3 over 2.
60 degrees, if we convert it to degrees.
60 degrees.
Yes. Which now makes this a 30-60 triangle with a hypotenuse of 1. So let's solve this triangle with a hypotenuse of 1 Whatever the y measurement is, that'll be the y point of the terminal point, and whatever the x measurement is, that'll be the x measurement. So let's go back to our unit special 30-60 triangle. What's the dimensions on this?
Is it like 1 dash root 3, 2? Okay, yeah.
Okay. So if this is the dimensions of our unit, what are the dimensions on this thing here?
So the hypotenuse would be, would you change it to 2 or would you keep it?
No, it's 1. But what that means is the similarity ratio is 1/2. In other words, if you take our hypotenuse of 1 and divide it by 2, every side over here has to be half of this side over here.
Yeah.
So the y-coordinate would be 1/2. The x-coordinate would be root 3 over 2.
3 over 2.
So this
It would be y would negative 1/2.
Right. No, the y is positive, but the x is negative. So the answer is negative 3 over 2, comma, 1/2.
I thought, so when you're going from reference angles, you're going from 0. It goes pi over 6, pi over 4, pi over 3, pi over 2, right?
There's pi over 6, there's pi over 4, there's pi over 3, and there's pi over 2, 90.
So I thought pi over 6 was root 3 over 2, comma 1/2.
It would be positive root 3 over 2. Because notice that if I'm looking at this triangle here, that's a 30-60 also, so it has the same dimensions. It'd be 1/2 and root 3 over 2, but notice we're going in a positive direction on the x and a positive direction on the y. So this point right here would be 1/2, root 3 over 2, comma 1/2. They're both positive, the x and the y, of this point right here. Remember, that's first quadrant. Everything's positive in first quadrant. In the second quadrant, the x measurement is negative, but the y measurement is positive. If I was in the third quadrant, both would be negative. Notice the x is negative, the y is negative. And in the fourth quadrant, the x is positive, the y is negative. So
the book says that the answer is negative 1/2, comma root 3 over 2. That's what I think it is too, because all pi over 3 angles are root 3 over 2, comma 1/2. Or no, 1/2, comma root 3 over 2.
Oh, you're right, because it was the 60-degree angle was the reference angle. I'm sorry, I made that 30. In other words...
Okay, I was confused. I was wondering why you were flipping the points.
Yeah, you're right. This was 2 pi over 3, which is 120 degrees, and this was 60 degrees. So it's a 30-60 triangle, but opposite the 30 is the 1/2, opposite the 60 is the root 3 over 2, which makes the coordinates minus 1/2, root 3 over 2. My mistake, sorry.
So I guess let's try another one.
Yeah, let's do definitely one more after I screwed that up.
This one's a harder one.
Okay.
Negative 41 pi over 4. Alright, so find out how many times it goes. It goes around 10 times, I see.
Okay.
Or, I mean, it goes around 5 times.
Right. What we want to do is take away as many 2 pi's from that as we can. So this is the equivalent of minus 10⁻⁴ pi, correct?
Yeah.
So after you've taken away the biggest multiple of 2 pi, what do you got left?
Pi over 4.
Minus.
Minus pi over 4.
Which is
so then the reference angle, would it be negative pi over 4 or would it be positive pi?
It'd be negative. because we're going this direction, so it's negative angles.
So for the reference
you could
angles,
also call it 7 pi over, or excuse me,
no. Yeah, 7 pi.
7 pi over 4. In other words, this angle is 7 pi over 4, which is equal to minus pi over 4. Equal in a sense. In other words, it's a coterminal angle to minus pi over 4. But it's okay to leave it as minus pi over 4. It puts it in the right quadrant. So we know that our x is going to be what sign, and our what's the answer?
The answer. Oh, all right. Wait, what's the answer for?
Here's our triangle. It's going to be a 45,
Oh,
45.
It's root 2 over 2 comma negative root 2 over 2.
Right. Because the x measurement is positive. This is a positive measurement. The y measurement is negative. And root 2 over 2. In other words, I can write this thing as, now hold on. If this is our standard, and this is 1, then our similarity ratio is square root of 2 divided by 1. So this would be root 2, and this would be root 2. No, over 2. Sorry.
Yeah, over 2.
Yeah, over 2, because this is a bigger triangle.
So so basically, for every single reference angle, I've basically just gotten pi over that denominator that they've given me.
Okay.
For every single one. Is that the case always, or are you
Yeah.
going to get a different reference?
No, it's always going to be pi over something. In other words,
no matter what they give you, like, I could just tell it's negative pi over 4 from looking at it.
From looking at minus 41 pi over 4?
Yeah, for a reference angle.
Okay, well that's good. But you have to subtract a multiple of 2 pi away from that.
This is why I'm confused. Like every reference angle problem has just come out to pi over.
Okay, what if it's 39 pi over 4?
All right, 39 pi over 4. 4 goes in 9 times, leaving 3 pi over 4.
Remember, you have to take out multiples of 2 pi.
Yeah. So then it basically, you go around, so it'd be 8 pi then. You go around 4 times.
Right.
And then you'd have 3 pi over 4, so you go over
You'd have
to
7. You'd have 7 pi over 4 left over.
Oh yeah, I forgot because we took out that one. Yeah.
Right.
All right.
We took 30.
So then you go to the third quadrant.
Well, 7 pi over 4, if I'm going this way.
Oh, okay, so it's negative. I thought we were doing quadrant. So then, yeah, it'd be in the first quadrant. But then still the reference angle will be pi over 4, right?
Yes.
So yeah, that's what I'm saying. All reference angles.
Well, they don't all end up pi over 4. They can end up pi over 3 or pi over 6 or pi over 2.
Yeah. Like what I'm saying is, do all reference angles, so no matter what, you get 5 pi over 4.
They don't. The reason these are all like that is because they're dealing strictly with multiples of 30, 45, and 60 degrees at this point.
Okay, it's because we're just, okay.
Yes, that's the only reason we're getting all of those answers. In other words, pi over 12 is an angle. That's 15 degrees. So once you get beyond just 30, 45, and 60 degree angles, you'll have numbers different than pi over 4, pi over 3.
That's what I was confused on.
Yeah.
I didn't know if, so I was like, this is too easy.
Yeah.
Okay.
Well, that's because you haven't really gotten into the next segment of trig yet. The first segment of trig deals with just 30, 45, and 60 degrees. And in fact, the unit circle that they want you to memorize is broken up into just those multiples. Like you
that's why I
said,
have it memorized.
pi over 6, pi over 4, pi over 3, and then every other angle is a multiple of one of those.
Yeah.
But there's still pi over 12, which is a 15-degree angle. And there's pi over 100, which who knows what that angle is. But yeah, you can have any angle you want. It's just that they haven't introduced those to you yet.
Okay.
Have they given you problems like find the sine of 210 degrees?
No, this first chapter today really only dealt with trigonomic functions, unit circle approach.
Well,
So I think that's all we were dealing with this first.
well, that's
Let's go over the second.
that's part of this. Yeah. In other words, if I look at 210, what quadrant is that in?
Don't tell me. So I got 180, 180 plus 90. That'd be in the third quadrant.
And what's the reference angle?
So you do 210 minus 180, correct?
Uh-huh.
So then 30 degrees.
So the sine of 210 is the same as the sine of 30, which is 1/2, only is it positive or negative in the third quadrant?
Negative.
Because all students take calculus. All 6 trig functions are positive in the first. Sine and cosecant are positive only in the second. Tangent's the only one, and cotangent that's positive in the third. And cosine and secant are the only ones positive in the fourth. So this technique where you convert this angle to a first-degree angle is very useful to come up with the number part of the answer. Now, to assign a plus or minus sign to it is easy based on ASTC. So, what is the sine of 150 degrees?
It'd be in the second quadrant. It'd be 30 degrees.
So it's the same number as 30.
Except this time, it's positive.
Yeah.
Because it's in. Yeah.
Because it's in the second quadrant. So using this technique, let me just give you 3 very important pieces of information. In the second quadrant, you take 180 minus the angle. In the third quadrant, you take the angle minus 180. In other words, for 210, you took 210 minus 180, and we did all of our figuring based on a 30-degree angle. In the fourth quadrant, it's 360 minus theta. Same as the second, only 360. So, what is the sine of 315 degrees?
360 minus 315, 45. Pi, it'd be negative, it'd be pi over 4, no, 7 pi over 4, which would be negative root 2 over 2. Yeah.
Okay, now see, what I would have done there was I would have just come up with a 45-degree angle as my reference angle. So I know it's root 2 over 2. And now it's in the fourth quadrant, so I know it's negative. So I would have gone through a multi-step, getting the number first and then assigning a sign to it. And doing that, you can solve any trig function of any angle that's a multiple of 30, 45, or 60.
I sent you two problems just now, or 3 problems.
Okay, let me open them up here.
Disregard that. Those 2 I sent were the exponential ones still.
Okay, so we want, is this a trig?
This one.
So you want this one.
Yeah, that last problem, yeah.
The circle one?
Yeah. Terminal points determined. So I guess this is where you convert the pi into an approximate answer.
So when they say t equals 1, oh, they mean this line right here?
Mm-hmm.
And they need the coordinates at that point?
Yeah.
Okay, notice what they've done here. How big is this circle? What's the circumference of this circle?
2 pi.
Exactly, because it's 6 point something. It's 6.28. So they've split this circle up into 2 pi. So what does this 1 mean?
That pi over 3. Yeah.
Exactly.
Or it's pi over 3. Yeah.
Right, because the whole circle is 2 pi, and this is 1 divided by 2 pi. Hold on a moment. So this point right here, isn't that 1 divided by 2 pi? I haven't, just a second, I'm trying to get my logic here. Let's see, that's pi over 2. That's pi. Well, that makes sense that that's pi. 3.14 is equal to pi. So 1,
This is just a weird looking like circle.
it's very weird that they do it this way. That's why I got to think about this for a moment. Let's see. If that was the point, I would say 3 divided by 2 pi, which is 3 over 6.28, which is a little less than half. And that is a little less than half that circle. So 1 over 2 pi is correct. For that arc length. That's not what I want, though. So this problem is supposed to be exactly the same as the ones above it, right?
Yeah. It's just, I think all you're doing is converting radians to like approximate answers. So like pi divided by 3. I know it's close to 1.
In other words, t is an angle. All of these t's are angles up here. So this t is an angle here also. So if that angle is, why'd you say pi over 6? Or you said pi over 3?
Because pi over 3, when you just do pi divided by 3, it's close to 1.
But it wouldn't, it's close, but it's not going to be that. You see why? If this point was pi over 3, then 6 times that point should be the full circle. But 6 times that point puts us to here, which is not 2 pi. So that point can't be pi over 3. Pi over 3, it's got to be 1 over 2 pi, which is a very similar number. 1 over 6, no, hold on. 1 over 6.28 is not the same as pi over 3. Am I getting confused?
Alright. So for 53, they said the answer was 0.5 comma 0.8 for the t equals 1.
0.508?
No, 0.5 comma 0.8. That's like the terminal point.
0.5 comma 0.8.
Yeah, that was the terminal point they got.
Okay, so Let me draw this. Which makes this 0.5 and that 0.8, and that clearly is 1, right? Because it's the unit circle.
Yeah.
Or is it? Is it necessarily a unit circle? That squared is 0.64. This squared is 0.25. That's 0.89. No, it isn't 1. So this is not a unit circle.
Yeah, no, I was just going to say, I just thought it's a figure. I just don't get this.
Well, this angle is 1. But what is that angle? Because well, if I say that, okay, here we go. If 2 pi is equal to 6.28, then what is 1 equal to? Well, I got to divide everything by 6.28, or 2 pi. So I would have I'm not sure why this problem is giving me difficulty, but it is. See, that is not 1/6 of the circle, so it's not 1/6 of 2 pi. So it's not pi over 3. What part of the circle is that? That's 1 over, it's this part of the circle. 1 over 2 pi part of the circle. So that's the angle. If we convert that to degrees, what do we use? We use pi over 180, which gives us
pi over 180. 0.017.
But it's not that. It's not 1 over 360 is the angle. Hold it. This is just a straight geometry problem. We have not 1/6 times 2 pi, but we have 1 over 2 pi times 2 pi, which is equal to 1. But what angle would that be? It would be less than... How do you get 0.5 and 0.8 from this?
That's what I'm saying. I think it's because, are they plugging it into the x squared plus y squared equals 1?
No,
I don't see how you would get it,
doesn't come out to be 0.5 and 0.8. And this is not the unit circle. This angle is what's puzzling me, because they normally give angles in terms of degrees or radians. What is that angle? That angle is slightly less than 60 degrees.
This is just the weirdest question.
Do we have another one we can work on? I hate to get stuck on one problem that I can't figure out.
I don't feel like this is going to be a big thing, though. Just go to that next link.
That's a very weird question. After I think
I've never even seen it like that.
If I think about it for a half an hour, I'll probably figure it out, but it might take a half an hour of thinking about it.
Yeah.
So,
see, the next two are just word problems.
all right, let's look at this one. Find the terminal point for pi over 6.
Just to clear off. Hold on.
Uh-huh.
Let me go to the answers. So it's just pi, or 1/2 comma root 3 over 2.
Well, pi over 6 is a 30-degree angle. So it's a 30-60 triangle. So we know it's 1 root 3, 2. Why are the distances PQ and PR the same? Suppose the terminal point and the points P and Q are shown in the figure. Why are the distances PQ and PR the same? Because the distance formula gives the same answer.
Probably.
In other words, the distance between P and Q is 2y, right? You see that?
Yeah.
Y minus minus y, so it's 2y. And the distance between R and P is the square root of x squared plus y minus 1 squared, using the distance formula also. And that also equals 2y. So those two lines are the same length based on the distance formula. So simplifying this equation using the fact that x plus y equals 1, solve the simplified equation. Okay. You are getting some weird trig problems. I thought I had seen every trig problem.
This one's like not even really a problem.
This one, they are starting you out on trig so weird. For one thing, they're starting you out with very hard concepts to understand. Trig's hard enough as it is. You should start out on the easy slopes and then go to the medium and then the expert. But let's solve this equation like they suggest. If we square that, we get y squared minus 2y plus 1. And all of that's equal to 2y. Now, simplify the equation using the fact that x squared plus y squared equals 1. And why do we know that? Because it's a unit circle.
It's the equation of a circle, yeah.
Well, it's a unit circle, so that hypotenuse is 1, which means x squared plus y squared has to equal 1. Okay, so if I substitute 1 for that, I get 1 plus 1. So now inside the thing is 2 minus 2y equals 2y. That will solve for y. If I square both sides, I get 4y squared equals 2 minus 2y. And now I get, well, that became a 2. Because I had plus 1 over there, plus another 1 there.
Well, I thought you plugged in 1 for x squared, 1 for y squared.
No, 1 is equal to x squared plus y squared. Right over here?
X squared, yeah.
So where I found my x squared plus y squared, I just plugged in a 1 for it. Right here.
Oh, okay, yeah.
And I got 1 minus 2y plus 1, which is 2 minus 2y.
Okay.
So now we solve this, and we're going to come up with a y. I'm going to divide both the sides by 2 here and move everything over. So I have 2y squared plus y minus 1 equals 0. I solve this for y. I got 2y minus 1,
2y.
Y plus 1.
Yeah.
So y equals 1/2 or y equals -1. Well, we can see that it's positive. So we know it's 1/2 is the y answer. And since x squared plus y squared has to equal 1, then x must be square root of 3 over 4. Let's see. I know that x squared plus y squared equals 1, and if y is 1/2, I got x squared plus 1/4 equals 1, x squared equals 3/4, x equals square root of 3 over 2. So my terminal point is square root of 3 over 2, comma, 1/2. That's the coordinates on point P, which is what they wanted, right?
Yeah.
Okay.
Right.
Very difficult problem, though. I can't believe that that's what they're starting you out with in trig. That would be a difficult trig. That would be a difficult trig problem for somebody that was ending trig. All right, let's
Probably going to be test problem or something.
This
Yeah,
should
let's do the second one.
this should be a similar one.
So I'm gonna try this one.
Okay.
Now that you know the terminal points, use the symmetry to find the term. So t equals pi over 3. You'll have your equation 2y equals x squared plus y minus 1 squared. So I plug in pi, no.
That's our first one. Now
Yeah,
pi over 3 is twice that size.
Hang on, I'm just finishing up with David.
Okay. Oh, you're talking
Okay,
about
bye.
your mom?
Well, my mom called me.
Okay.
So yeah, that's the point. I mean, you would plug 1 in, right?
Well, we know it's a unit circle. In other words, when we got the terminal point for this, it was based on a hypotenuse of 1. Because that's the only way you can say x squared plus y squared equals 1, is if it's the unit circle. Okay? So they say based on symmetry, so we just have a different triangle to solve is all. This is now 60 degrees. This is still 1. So what are our coordinates? What's our x and our y dimensions?
Alright. X, root 3, y 2. Or y.
Remember, opposite the 30 is always 1. So if I look at my triangle and look at the dimensions, there's 1, this is root 3, this is 2. But this triangle has a hypotenuse of 1, so everything is half. So if I made that 1, this would be 1/2, and this would be square root of 3 over 2. That's 60, so opposite the 60 is square root of 3 over 2. So this is square root of 3 over 2. Opposite the 30 is 1/2.
Yeah.
So what is the coordinates of that point?
Root 3 over 2, comma 1/2.
No, it's the opposite. Switch them.
Oh, yeah. 1/2.
Okay, because x is 1/2.
Yeah.
So it's 1/2 comma root 3 over 2. And that's what they meant by symmetry. Is if we double the angle, you switch those two values. A very, very subtle point for trig.
Alright. So when is the appointment for next week? They're 10 to 11 or they're 12 to 1? I don't remember which one it is.
I'm sorry, what? Do we have...
Am I for...
I don't...
Yeah, Monday, Wednesday, Friday next week.
Monday, Wednesday, and Friday from 10 to 11.
Alright, good.
Okay?
So that's how I set them up so they're right before my calc class, so I can go over the...
Okay.
So I guess that covers this chapter then.
Okay. That is a weird beginning for trig.
Yeah.
Talk about
They
trying
skipped all the subject OS stuff. That we didn't.
totally confuse you, yeah. I'd be confused, and I know trig.
Yeah.
All right. You got any other questions for tonight? Still got a few minutes if you want.
look at the 5.2 really quick. No, I think we'll be good for tonight.
Okay.
All this stuff is like all for next time.
Okay. We'll look at it on Monday then.
All right. Thanks a lot.
Okay, Mike. Talk to you on Monday.
See ya.